In this video, logarithms. Let's start off by looking at some identities and properties of logarithms. The first one is the log base b of b. What is this equal to? 1. In terms of exponents, my base is b. I want it to be equal to b. What power do I put here? First power, it's b. b is b. My base is itself. The next property, the log base b of 1 is equal to what? 0. In terms of exponents, if I have a number, what power do I need to raise it to get 1? The answer, 0. The third property I want to think about is the log base b of 0. What is that? Simple. Does not exist. Likewise, the log base b of negative 1 also does not exist. If I have a number and I want it to be equal to 0, I need to find some exponent in there, but there's no such number. You take two numbers, you multiply them together, and you get 0. Well, that means that a or b, one of these two numbers, is 0. Guess what? This guy is not 0. So, b to some number, it's not 0 either. Exponents are products, and logarithms talk about exponents, so logarithms have to deal with the product rules too. That is to say, if you take two numbers and you multiply them and you get 0, 1 or both is 0. 0 product rule. So why does this not exist? Well, here's an idea. Take 2, multiply it with 2, then multiply it by 2, then multiply it by 2. And keep doing that. This is never going to be less than 0 no matter how many times you multiply by 2. Well, what if you have a base and you raise it to something negative? That's the reciprocal. And likewise, if you take 1/2 and you multiply it by 1/2 and you multiply it by 1/2 and you keep doing that, it doesn't matter how many times you multiply by 1/2, that's never going to be less than 0. And this slash means not. It's a negation. It means it's not happening. Why? Because this guy is positive. And a whole bunch of positive numbers multiplied together are not going to give you a negative number. Next, let's think about how to combine exponents. There's 3 rules for combining exponents. The first is what happens when you have two logarithms and you're adding them together, or external addition. Notice how both of these are common logs. These are both base 10. Or they have the same base. I'm going to take 3, I'm going to take 2, I'm going to multiply them together. 3x times 2x, and this will be inside a logarithm of the same base I started with, base 10. And this simplifies to the log of 3 times 2 is 6, x times x is x squared. Log of 6x squared. External addition means internal multiplication. External addition means internal multiplication. What happens when you have a difference? What happens when on the outside of the logarithms you're subtracting? Well, subtraction is the opposite of addition. When we had addition, we multiplied. The opposite of addition means we're going to do the opposite of multiplication. I'm going to take these two right here. 12x goes on top. And this has the negative sign right here. So 2x goes on the bottom. It's what's negative that ends up in the denominator of our new combined logarithm. And we can go ahead and combine this. You get the log of 6. So external subtraction means internal division. The last rule for combining and manipulating logarithms is what to do with exponents. And it's kind of weird and it's not intuitive, but this exponent can actually jump outside of this logarithm. So we could have 2 times the log of x. Now if we had something like from our first example, logarithm of 6x squared, well, we can just take that 2 and pop it outside, right? And then we get 2 times the log of 6x, right? Well, no. Because everything inside this logarithm has to have a 2 taken out of it, in a sense. It has to be unsquared. We have to take the square root of it. So it's not 2 log 6x, it's 2 log square root of 6 square root of x squared. So unless they're both squared, it's probably a bad idea to take out that exponent. And this isn't just for squaring. If we have something like this, the log, we'll say base 4 of 16x to the 4th, that would be equal to, we can take out a 4 and get 4 times the logarithm of 2x, because 2 to the 4th power is 16. I manipulated both the x and the 16, everything inside of the logarithm. Let's put this all together and look at a nice big example here. When we're combining, what we want to look for is things with common bases. My common logs, these are both base 10. The natural logs, these are both base e, and that's how I'm going to combine these things. We'll handle the common logs first. This is the log of 6x plus the log of 2y. Well, it's when we combine them, it's also going to be a common log, and it's going to be of 6x times 2y. To that, we're going to add the natural log of, let's see here, this will be y, and this is negative, so that 3x is going to go in the denominator. We'll put some nice big parentheses around it so that we know that entire fraction is the argument of this logarithm. we can combine these. This is the log of 12xy plus the natural log of, and we can't really combine this, y divided by 3x. Alright. Let's take a look at one last example. Like before, we have common logs and we have natural logs. So what we want to do first is we want to combine these two. But there's a problem. Previously what we had was log of 6x, log of 2y, log of. That's not what we have here. We have 2 times the log of x plus 3 times the log of y. And take a look here. Multiplication comes before addition. So before we add and combine these logs, we have to take care of this multiplication. How are we going to do that? The opposite of what we did right here. We're going to take the exponent, and this time we're going to move it into. So this 2 is coming inside, and this 3 is coming inside. So what we're going to have is the log of x squared plus the log of y cubed. Let's make that green. Now we can combine, and we'll just multiply log of x squared y cubed. Can't combine those, they're different bases, so that's done. That's this bit handled. 1. Now let's take a look at the natural logs. There's nothing on the outside, so we should just be able to combine them. So let's see here, this one is negative, so it's going to be on the bottom. And we'll have the natural log plus natural log, and nice and big, this goes on the bottom 2. Okay, and then, well, this is negative 2, so it goes on the bottom. Okay, well, we're left for nothing on the top. You know what's a nothing with logs? 1. So what goes on the top here? 1. Nothing else to combine, so we're done with that one. This is the natural log of 1 over 2y. 1. So when it comes to combining logarithms, remember, addition means we're going to be multiplying what's inside. Subtraction means we're going to be dividing. Multiplication gets turned into an exponent. It's a little weird, but then again, everything with a logarithm is. See you next time.